Johnny here with Simpson Math. In this quick video, I want to talk about weight versus mass and explain that they are not the same. It is a common confusion or misconception because when we talk about weight and mass, we kind of blur them together and it can be very confusing. So whether you're in Calculus 2 learning about force and density, or some college algebra class, or you're doing some like multiplication problems, that the idea of weight and mass can be confusing, so I'm going to hopefully clarify it up a little bit. Or this is how I think about weight and mass. So it all boils down to one of Newton's laws, which just says that weight force is equal to mass times gravitational acceleration. Okay, what does that mean? Okay, that means when we step on a scale, and let's say we're in the metric system, and it tells us we weigh a certain number of kilograms, well, that's not the weight, that's the mass. Mass is the quantity of ourselves, like how much is in us. And it's also like a measure of inertia, but I think of it as mass is just like our quantity. Weight is a force. So we are being like pushed onto the earth. It's a weight force. And then the gravitational acceleration is just when you drop an item, the free fall, like basically how fast does it fall toward the earth, that gravitational acceleration. All right. So let's just do a quick little example here. I'll start off with the metric system. Let's say we weigh an item and it weighs 1 kilogram. Kilogram, but we typically call that a kilo. Well, in the metric system, the gravitational acceleration is about 9.8 meters per second squared. So then the weight, that amount of force that we're being kind of like pushed down almost, is just the multiplication, 9.8. And this unit of measure is called a Newton. Force is measured in newtons. So when you step on a metric scale, it really should calculate your newtons. That's your weight. So it's very confusing because we talk about kilo as a weight, but that's more of a mass. Yeah, quantity of matter. Okay, so newtons is how much you weigh. So if you want to actually know your weight in newtons, you need to multiply by 9.8, and you actually weigh more newtons than you do kilos. Okay. Now, this is even more confusing when we start to talk about the British imperial system. Here we're talking about pounds. So let's say I have an object, I've weighed it, and it weighs 32 pounds. This is the weight force. So when you talk about I weigh kilos or I weigh pounds, notice it's confusing already. Okay. In the British imperial measuring system, the gravitational acceleration is about 32 feet per second squared. In fact, I should make these little equal signs. They're approximately equal to. It's about 9.8. It's about 32. So if I want to know, well, what's the mass of an object that weighs 32 pounds, I simply divide by the 32, and this is 1, and this unit is not commonly referred to. Like, we don't talk about it much, but this is called a slug. 1 slug. So 1 slug, that's a quantity of mass, on the Earth weighs 32 pounds. 1 kilo on the Earth weighs 9.8 newtons. Weight is a force. Mass is just a amount, like a quantity. And then the gravitational acceleration is that the closest, biggest object, what it's pulling, that rate at which it's pulling you toward. Okay. Maybe a little quick example we could do is, I know that I have a mass. See, even I do it. I even talk about mass as weight. We gotta stop that in our common language. But I know that I have my mass, I've calculated it, and I have 6 slugs. And I want to know, well, how much do I weigh? Well, I simply multiply by 32 feet per second squared, and that's going to give me 193. That goes even, 193 pounds. All right. Anything else? Oh yeah. So the next time you step on a scale, if it says that you weigh 87.5 kilos, well, that's not your weight, that's your mass. Your mass doesn't change as you go from like the moon to the earth to Jupiter to Mars. The mass stays the same. So let's say you step on a scale, your mass is 87.5 kilos. You multiply that by the gravitational acceleration, 9.8 meters per second squared, and you will weigh roughly 857.5 newtons. Yeah. All right. Hopefully this kind of clarifies weight is a force. Mass is just this quantity, how much is in you. And then the gravitational acceleration on Earth these are the common ones that we use, but this will differ depending on what you're talking about. If you're talking about being on the moon, I think the gravitational force there is 1.7. Is that in feet? I've even forgotten. Those are different accelerations. All right. See you in the next video.